Okay, so let's work this problem. This one will be pretty simple, one to get started on. This is very similar to the one we just did. We can just talk for a second about stability and determinacy. If you look at the structure as being all solid in one piece, does it have the right external reactions for stability? Yeah. The reactions are not parallel. They're not all concurrent, so that's good. We can find those too. There's two at A and one at C. We'll probably define the reactions first. And then looking at the truss, well, it's just a single triangle, so it's pretty stable. But if you had to do your accounting, you would have 3 reactions. You'd have 3 bar forces. That's 6 unknowns. And you've got 3 joints, A, B, C. You have 6 equations and 6 unknowns. So let's start first. I'll come over here and I'll just draw. I think I'll cheat. I'll just use this as my free body diagram. And I'll just assume that I'm going to replace A with a reaction in the Y direction, a reaction in the X direction, and then at C, it's a roller. I'll replace that with a Y component also. So I want to try and find those reactions. So I could sum forces in the X direction first. There's only one force, no applied X force, so that'd be easy. I can't sum forces in the Y direction first. There's 2 unknowns, 1 equation. But I can sum moments. And like we mentioned before, you could do A or C and be successful. I always like to go to the pen to start, so we'll do that. So I'm going to assume right-hand rule, and we are going to sum moments about A and make sure that's in equilibrium. So there's our equilibrium statement for that. So I'm looking at how the moment about A for each of these 2 forces. Let's start with CY. Is that going to be positive or negative for a moment? About A. It's going to be positive. So the force is going to be CY. And the distance from A to C is 5 meters. Then I've got this 60 kilonewton force going down. What kind of moment does that create about A? Positive or negative? Negative. So it's negative. The force is 60 kilonewtons. And what's the distance from A to that line of action? Looks like 5 plus 5, it's 10. So we should be able to solve for CY pretty quickly. Looks like CY is going to be 120 kilonewtons, and it's positive. So any questions about that? That's pretty simple. So now we can either sum forces X or Y and be successful. I'll just go for Y first. So we will sum forces in the Y direction. Again, we'll say that's an equilibrium, so there's our statement. So let's do that. I'm assuming up is positive, so AY I assumed was up, positive. I assume CY was up, positive. And I got the 60 kilonewtons, which is acting down, that would be negative. And of course I can put my CY right in there. I should be able to solve for AY. What do we get? I think I got negative 60. You guys see that? Negative 60, and that's kilonewtons. Does that make sense? Well, I like to think of this problem kind of like a seesaw. Like there's the pivot of my seesaw. If you pull down 60 kilonewtons here to balance it, you better pull down 60 kilonewtons there. If you don't, you're going to be the skinny guy up in the air. Right? I was always the skinny guy up in the air. Let me down, let me down. All right, see that? So that makes sense. And then just to finish this off, I'll sum forces in the X direction. And in this case, all we have is AX. So that's just 0. So I got 3 of my unknowns pretty quickly. So you already worked this problem, chapter 2. This could have been any kind of structure up here, any solid piece. And now we want to go back and see what are the bar forces in here. So where should we start? We can go to joint A, B, or C. let's just ask a simple question. Can I write two equations and two unknowns at A? Yes. You really delayed on that one, didn't you? Yes. How many unknowns are there? Well, there's a bar force in AB, a bar force in AC. I've already got my reactions, right? Two equations, two unknowns. How about at B? Can I do it there? How many unknowns there? 1, 2. Yep. Two equations, two unknowns. What about C? Yeah. So where should we start? We can go anywhere we want. Think about the one that's the easiest to do. And as an example, I'll give you the one that's the hardest to do. B. Why would B be a horrible place to start? What kind is let's say I'm using standard XY, that means BC has XY components, right? And what does BA have? XY components. That's two equations and two unknowns. You have to solve that simultaneously. I don't think you want to do that. What if I go over to A? Does AC have XY components? It has an X component. Does it have a Y component? No. So that means AB is the only one with a Y component. So that's a good place to go and start with summing forces in the Y direction. The same thing could be said for C. Same idea. You've got one that's just an X and then one XY. So I think I'm going to go A, I'm going to go C. I'm going to leave B alone. Just for the geometry and all the trouble up there. I'm just not going to do it. Now, I can get my results and then plug them into my B equations and check to see if they're in equilibrium. That will make sure that I have the answers correct. I don't know if I have time to do that for you guys today. So let's start with joint A. This is a very challenging object to draw. There. That's my free body diagram for A. Can you guys do that? You don't need a circle template. You can freehand that. Now what's acting on A? What's the AY value? Negative 60. So it's actually down. I'll put those in blue just to let you know that we found those. And then what's AX? 0. Okay, that's done. Now I'm going to assume tension in AC, and I'm going to assume tension in AB. Now I have had people ask me about this, the nomenclature, how I number these things. They say, you're going from A to B, so that's why you're calling it AB. I don't do that. I do this alphabetically. So you may go over to physics and they have a different kind of system. Like if I want to draw a vector from B to A, it may be numbered BA, tail to head. I don't do that. And you don't worry about that. I just use this to keep track of what element I'm in. And I'll just do it alphabetically every time. What's the slope of this guy? It looks like horizontally it moves how far? 10. And then it rises how far? 5. So divide that by 5 and I get a 2-to-1 slope. See that? And if you had a right triangle with legs 2 and 1, what would the hypotenuse be? No. 2 squared plus 1 squared, take the square root, would be square root of 5. So now, if I sum my forces in the, what direction first? X or Y? Y. We don't want to do X because we have two unknowns in one equation. So we'll do Y first. And when I sum forces in the Y, what do I get? Well, I get the Y component of AB. That would be the 1, right, going up. So that's 1 over the square root of 5 times the force AB, and that's going up. What else is acting in the Y direction? Negative. The reaction, it's down, so it'll be negative 60. So what is the force AB? It looks like it's positive. And whatever 60 times the square root of 5 is. 132.7. Oh, close. 134.2. And that's kilonewtons. It came out positive, so what does that mean? It's in tension. Does it make sense that AB is in tension? I think it does. You've got kind of a system here. Gravity loads. Top chord would go in tension. Bottom chord would go in compression. Let's see if that holds true. Any questions about that so far? So now that I have this component, I can now sum forces in the x direction. So in the x direction, I'm going to assume right is positive, so I've got AC to the right, so that's positive. I've got the horizontal component of AB, it's also to the right, so that's positive. And that'll be 2 over the square root of 5 times FAB. What else do I have in the x direction? Nothing. So I should be able to put that right in there. And when I solve for AC, it looks like I'm going to get a negative value, and it's going to be 120? I'm guessing. Is it 120? And where is AB? I'm sorry, AC. It's kind of part of the bottom chord, and we know in gravity loads the bottom chord is usually in compression, so that's matching too. I like that. So how many unknowns do we have left? Let's see. We've solved for 1, 2, 3, 4, 5. We only have one left. Just for note-taking purposes, I'll put a little squiggly line and say, hey, I've got that one. I've got that one. So what do I need? I just need BC. Now, can we go to B? Sure. It's going to be a little bit of a problem, because you're going to have to take this solution from AB, and it's going to be kind of messy doing all the different angles. So you could do it, but I think C is going to be the easiest one. We've talked about it before. So you've already had AC, which is X. So all you do is come to C and sum forces in the X direction, and you'll get BC. So let's draw the free body diagram for joint C. Again, I'll work hard on that. Got it. What's CY? 120. We assume that's up, so it's still there. So I got a force acting up of 120, and that's kilonewtons. Now, I always assume tension, so I don't have to think about it, but just to correlate it, since I did assume tension here, and if you did assume compression, you've got to be equal and opposite on the other side. So I don't have any choice. I've got to go this way. Now, I am choosing direction for BC. It's the first time I've looked at that. But I always do tension, so I'm not going to think about it. I'm just going to go ahead and assume tension for the force in BC. And there's some angle there, so let me look at what the slope of that is. So it goes over 5 and goes up 5. So that's a slope of 1 to 1. So what's the hypotenuse? Square root of 2. Now, I want BC. I can either sum forces in the y direction and get it, or sum forces in the x. Which would be the best way to go? Well, if I sum forces in the x, what controls the solution of BC? My solution for AC, which I could have gotten wrong. So I would think it'd be better to go in the y direction with this. I feel more confident about my value there. Either way, I could have made an error in my reactions too. So which one did I say I was going to do? X? Y? Okay. So we'll assume that we've got up is positive. We'll sum forces in the y direction. And what do I have? I've got my y component of BC is up, and that's 1 over the square root of 2. That gives me the vertical component of BC up. And I also have acting up the reaction 120. So it looks like BC is going to be negative And I don't know what it's going to be. 169 point what? 7. That seems reasonable. And it's in compression. And again, this is kind of the bottom chord of my structure, so that being in compression. Plus, if you think about B, under this load, B would probably move down, right? And would probably force this section BC to get shorter, compression. And would probably then also push C which way, left or right? Left. So that means AC gets shorter. You can also relate it that way. So any questions about that? Really drug that one out. Yes?
When we did A, we flipped the direction of AY reaction, but on C we didn't.
Well, we did that because the AY reaction was negative.
Oh, okay.
And the reaction at C was not. So I just corrected these directions on the free bodies, the new free bodies. I didn't go back up here and change these, right? But I could change them here.